everyone, welcome to Sci 9 video lessons. Today, we're going to study about vertical dimension of uniformly accelerated motion, or UAM. Our objectives for today's lesson are: A. Describe the uniformly accelerated motion, or UAM. B. Solve problems involving UAM in vertical dimension. What is uniformly accelerated motion? In UAM, the value of the acceleration is constant, meaning it does not change. There is a changes in velocity but at a constant rate. How about acceleration? Acceleration is the rate of change in velocity with time. Formula: acceleration is equal to final velocity minus initial velocity divided by 2. It is also a vector quantity having both magnitude and direction. And what is free fall motion? Free fall, any object that we throw upward will go down because of the force of gravity. The freely falling objects exhibit uniformly accelerated motion. As you can see in the illustration, the apple falls freely on the ground, and the acceleration due to gravity is constant, which is 9.8 meters per second squared. Now let us try to answer the problem involving UAM vertical dimension. Example: dropping of object. If we drop an object, the acceleration due to gravity is constant, which is 9.8 meters per second squared. We can determine the height of the building by solving the time, velocity, final velocity, and initial velocity. In solving the word problem, first, we must draw an illustration regarding to the problem for us to visualize it and analyze. Second, know the given value and the unknown. The initial velocity is 0 meter per second squared. 0 because from at rest. We just drop the ball from the top of a building. The acceleration due to gravity is constant, which is 9.8 meter per second squared. And the time given is 45 seconds. The unknown is the height of the building and the final velocity. Again, in solving a word problem, we have some tips. First, remember the word guess. Guess. G means given. U unknown. E equation. S substitution, and S solution. Of course, in solution, there is an answer. So solution with answer. So what are the given? Initial velocity is 0 meter per second squared. Dropping of an object. Okay, constant acceleration due to gravity is 9.8 meters per second squared. And the time given is 45 seconds. The unknown is final velocity and height of the building. Alright, another one is E equation and S substitution. The equations are already given, but we must know how to derive formulas. Okay, equation height is equal to initial velocity times time plus 1/2 agt squared. For final velocity, square root of 2 agh. So 2 times acceleration due to gravity times height. In final velocity, we need the value of height. So first solution that we're going to solve is the first problem that we're going to solve is the height of the building. For substitution, so height is equal to 0 meter per second. The initial velocity is 0 times 45 seconds. So automatic, the answer is 0. So cancelled na in this part. Plus 1/2 times 9.8 meter per second squared times 45 seconds squared. Meaning to say 45 times 45 times by itself. Solution. Here is the substitution. For the height, 0 meter per second squared times 45 seconds is equal to 0. Plus 1/2 times 9.8 meter per second squared times 45 seconds squared. 1/2 times 9.8 meter per second squared, 45 seconds times 45, or 45 times itself is 2025 seconds squared. Cancel the second squared unit. Height is equal to 1/2 times 19,845 meters. The answer is 9,922.5 meters or 9.92 kilometers. How about the final velocity? Since our formula is final velocity is equal to square root of 2agh, we already have the value of height. 2 times 9.8 meter per second squared, or ag, times 9,922.5 meters. So this is the value of the height of the building. Multiply it. The answer is 97,240.5 meters squared per second squared times 2, 194,481 meters squared per second squared, square root. The final answer for final velocity is 441 meters per second. Now here is the illustration for our first problem with answer. Okay, the height of the building is 9,922.5 meters and the final velocity is 441 meters per second. Okay, next problem, sample problem number 2 about vertical dimension. Sample the object thrown upward. So as you can see in the illustration, the ball thrown upward. The acceleration due to gravity is constant, but this time you will see the negative sign, negative 9.8 meters per second squared. The sign is an indication that the direction is upward. If negative, upward. If positive, downward. Here are the given value for the problem number 2. Okay, the acceleration due to gravity is negative due to the direction of an object. Negative 9.8 meters per second squared. Moving upward, the acceleration due to gravity is negative. The final velocity is 0 meter per second. Why 0? As you throw any object upward, as it reaches the maximum height, the velocity will become 0 because the ball or any object, as it reaches the maximum height, it will momentarily stop. And then the total time is 2.5 seconds. The time you release the ball and the time the ball reaches the ground, that is the total time. So we're going to divide it into 2 to get the time for this problem. Time in second. And initial velocity is also unknown, and the height of the building. Given final velocity is 0 meter per second, acceleration due to gravity is negative 9.8 meter per second squared, total time 2.5 seconds, unknown, height of the building, initial velocity, and time. Equation. Time is equal to 1/2 of total time. Initial velocity is equal to final velocity plus AGT. Height is equal to initial velocity times time plus 1/2 acceleration due to gravity or AG times time squared. Substitution for time. Time is equal to 1/2 times 2.5 seconds. Time 1/2 of 2.5 seconds is 1.25 seconds. For the initial velocity, the final velocity is 0 meter per second plus 9.8 meter per second squared times 1.25 seconds. The answer for initial velocity is 12.25 meter per second. Substitution for formula in getting the height of the building. H is equal to BIT plus 1/2 AGT squared. Height is equal to 12.25 meter per second times 1.25 seconds plus 1/2 9.8 meter per second squared times 1.25 second squared. Solution. Height is equal to 15.31 meter plus 1/2 times 9.8 meter per second squared times 1.56 seconds squared. Height is equal to 15.31 meter plus 1/2 times 15.29 meter. The answer addition 15.31 meter plus 7.65 meter. The total height of the building is 22.96 meters. Now here is the illustration with final answers. The time is 1.25 seconds, the initial velocity is 12.25 meters per second, and the height of the building is 22.96 meters. Now let's have an exercises. Remember, in solving a word problem, first we have to analyze it, draw an illustration about the problem, and then remember the word guess: given, unknown, equation, substitution, and solution with answer. So let us try to answer this problem. Diana is playing with a ball on their rooftop and accidentally fell the ball on the ground after 3.5 seconds. What do you think the final velocity of the ball before it hits on the ground? Calculate the height of their house. Problem number 2. Ron J. throw the ball vertically upward as high as he can and record the time as it reaches the ground. The total time is 3.5 seconds. What do you think the initial velocity of the ball before it hits on the ground? Now, try to answer the 10-item quiz. 1. What is the value of acceleration due to gravity? A. 0 meter per second. B. 0 meter per second squared. C. 9.8 meter per second squared. Or D. 5 meter per second squared. For number 2, Mary throws a ball vertically straight upward with an initial velocity of 5 meters per second. What is its velocity at the highest point? A. 0 meter per second. B. 0 meter per second squared. C. 9.8 meter per second squared. Or D. 5 meter per second squared. Number 3. If the ball is hit vertically upward, what is its acceleration after 1 second? A. 0 meter per second. B. 0 meter per second squared. C. 9.8 meter per second. Or D. 5 meter per second squared. For number 4, blank is the motion of an object with constant acceleration. A. Force. B. Motion. C. Constant motion. Or D. Uniformly accelerated motion. For number 5, in uniformly accelerated motion, which of the following quantities changes at constant rate in a body? A. Acceleration. B. Speed. C. Time. Or D. Velocity. Number 6. A coin was tossed vertically upward. What is its instantaneous speed as it reaches the maximum height? A. 0 meter per second. B. 0 meter per second squared. C. 9.8 meter per second squared. Or D. 5 meter per second squared. Number 7. Identify which of the following will exhibit uniformly accelerated motion. A. A sleeping dog. B. A falling apple. C. A ringing alarm clock. Or D. A hanging wall decor. Number 8. Identify which of the following will exhibit uniformly accelerated motion. A. A sleeping rabbit. B. A falling leaf. A. A ringing cell phone. Or D. A hanging wall clock. For number 9, Amira throws a ball vertically straight upward with an initial velocity of 6 meters per second. What is its acceleration at the highest point? A. 0 meters per second. B. 6 meters per second. C. 9.8 meters per second squared. Or D. Negative 9.8 meters per second squared. Last question. Amara throws a ball vertically straight upward with an initial velocity of 8 meters per second. What is its velocity at the highest point? A. 0 meters per second. B. 8 meters per second. C. 9.8 meters per second squared. Or D. Negative 9.8 meters per second squared. That's the end of our video. Thank you for watching. If you like this video, click like, subscribe, and share. And also click the bell button for you in order to be updated in all videos. Okay, goodbye.